Hello, Norman Burton from betechnical.ca. I'm going to demonstrate one of our more advanced labs. This is lab 15 out of our VFD training workbook. And what it is a main pump. So this is a main variable speed pump. And what happens is it delivers water pressure. So it simulates delivering water pressure. And over here we have a fixed speed pump. And what's going to happen is when this pump cannot keep up with demand, right? So this motor is running, delivering pressure to the system, and when it can't keep up with the demand, or there's a high demand on the system, it's going to call up the second pump. So I'm going to get into the wiring in details and show you around a little bit, and then I'm going to run the system for you. So the wiring for the main and auxiliary pump control involves connecting a cable between the two drive systems. So we have a cable connected through this skin-tight connector over on here, through from one terminal strip to another. And what will happen is when this drive hits a certain threshold, it will call up an output from the drive, and it will tell that drive to turn on. Okay? We have a jumper, a fixed jumper on the main pump. So as soon as the power is turned on to the pump drive system, it just runs. So if there's a power failure in the middle of the night, it just runs. It doesn't need a signal. Okay? It just maintains pressure in the system. And it operates based on a signal from a pressure transmitter. Now, we are simulating a pressure transmitter with our potentiometer. So when the potentiometer is at full dial setting, so 100%, we have wired it so that when it's at 100%, the drive runs slowest. Because at 100%, your pressure is at max. And when the pressure drops, then the speed of the pump turns up. So you've got pressure drops, the speed of the pump turns up to maintain pressure, and so on. So it kind of balances. When the pressure drops to a certain level and the pump is at maximum speed and it can't maintain pressure, then it calls up the second pump. Okay, so now I'm going to power things up and demonstrate. So we're going to do a cold start on our pumping system, meaning we're just commissioning it. So we're going to power up the pumping system. Okay, remember we have that jumper in there, so we don't need any operator devices to tell the pump to run. It just runs, and its speed is based on the pressure transmitter, okay, which is the potentiometer in this case. So it's a 0 to 5 volt signal from the drive that we are manipulating, but we could also use a 4 to 20 milliamp or a 0 to 10 volt signal. There's options on that. Now, the pressure is at full pressure based on the potentiometer dial. As I turn the dial down, you're going to notice the speed of the motor is going to increase. So it's trying to maintain pressure, and you can hear it accelerating as I drop. Now, we've set up the drive so that when it reaches 50 hertz, it's going to call up the second pump. So you're going to see that second motor come on soon. So I'm around 35, 36, 40 hertz. So your pressure is dropping, the pumping system is trying to keep up. So there's a large demand on the system. I'm going to decrease the pressure, the speed of the pump is increasing, and soon you're going to see that second pump energized, and it's going to ramp up. I think we have it set on a 10-second ramp, because you don't want it hammering the water system. So we're about 49, 50, and there it goes. And you can see it's going to ramp up, and it's going to assist the main pump. Okay? I'm going to take the primary main pump right up to full RPM. Now what we're going to do is we're going to simulate a power failure. So if we have a power failure in the middle of the night, a storm, the lines go down, and then you have a transfer between utility supply to generator supply. A lot of pumping stations have that backup. I'm going to simulate a power supply by turning off this motor disconnect switch on the side of the main unit. And there's our power failure. It's very critical that when we switch over to generator and a utility that all the equipment starts up. So you always need to check your work and check to see how your system behaves after a power failure. So I'm going to re-energize. And you're going to see it power back up. Second pump turns on right away because the system was low on pressure, and away we go. And once we reach our pressure, we get up to a normal operating pressure, middle of the night when there's no demand. Pressure's coming up, speed's going down. Second pump turns off. And then when pressure is at its max, the pump will run at a low speed of around 20 hertz, and basically it'll just cavitate to keep water pressure in the mains. You always want to have maintained water pressure in your water main system. You always want to have pressure, because if you ever lose pressure, and you'll have ingressing from groundwater pressure coming into the system, which is a no-no. So that's our lab number 15. Main pump, variable speed, fixed speed, auxiliary pump.